So today we're going to be answering question number 15 from the book, and question 15 says, which type of function best fits each of the following graphs? Linear, quadratic, cubic, exponential, or step? And so we need to look at graphs A, B, C, and D to answer that question. Right now, don't worry about what I have starred. That's something I'm going to talk about in a little bit. So I think the first thing we should do is go over the definitions of the types of functions listed: linear, quadratic, cubic, exponential, and step, just to make sure that we know what those are, so then we can choose which one best fits each graph. So, let's see here. A linear function graphs a straight line, which means the function has one or two variables with no exponents or powers. So we're going to be looking for a straight line, and the equation is y equals mx plus b. And an example of a linear function would be an increase in pay. Let's move on to step. A step function is a function that remains consistent with each of a series of adjacent intervals but changes in value from one interval to the next. So the equation is f of x, and then this is just something that I made up. There isn't just one set equation like for linear. It's always going to be y equals mx plus b. With a function, you kind of get to make it up a little bit. So you'll first see f of x and then something similar to this. And step functions have to do with inequalities. So that's a good thing to remember, because these other graphs listed do not have to deal with inequalities. And an example of a step function is the number of pages read by time. Let's look at quadratic. Graphs a parabola, and a parabola basically looks like a big U, like a big capital U, and it can either open upward or downward. The equation for that is y equals x squared, and an example would be gravity on an object. An exponential function gets very close to the x-axis but doesn't cross it or touch it. The equation for that is y equals b to the x power, and an example of that is an airplane takeoff. And I think that's a great example because the graph looks can look similar to that. And cubic is an equation with a degree of 3, and the highest exponent is always 3. And this graph looks very curvy. It can have one curve in it. To me, some of them look like an S, or it can have a bunch of different curves in it. And the equation is x to the third power, and an example, a real world example of when we use cubic functions is in physics. So let's now look back at the graphs and see if we can't match the definitions and our examples to the graphs. So here we go. So let's look at A. So A looks like a pretty straight line to me. And if you guys remember, the definition of a linear graph is a straight line. So A is pretty easy. Linear functions aren't always horizontal. They can cross down this way, and they can also be vertical. So they can sort of be in any direction on the x or y axis, but it just has to be a straight line. So I'm going to label it linear. Then I'm going to cross it off our list so we know that we've got one down. Let's look at B. Something I want to point out are these little circles right here. They look kind of funny. That, this will give you a hint, has to do with inequalities. And so if the little circle or point is not filled in, it means that that point is not part of the graph, and if it is colored in so that it would be solid, then it means it is part of the graph. And I kind of gave it away by saying inequality. This is a step graph, or a step function, and if we go back over the definition, the step function, it's a function that remains consistent with each of a series of adjacent intervals but changes in value from one interval to the next. So you can sort of see that it's consistent, and it goes, and they're all adjacent to each other, and they change in intervals. And so, and it's also, if you just look at if you listen to the name, a step graph, those look like stairs. So if the definitions aren't helping, then you can just sort of try to remember what the picture looks like and go, okay, think of steps, or think of the name. Step, okay, I think of stairs, and then that's pretty simple because this looks pretty different from everything else, just like linear looks pretty different from everything else. These two, well, three, I guess, look more similar than the first two. So I'm going to label this step and cross that off our list. So let's go to C. C looks like a U. I guess it could be a V depending on how pointy you make it. Let's look at the definition of quadratic. A graph's a parabola. Parabola is a U shape. So it's pretty simple. This is quadratic. Looks like a big U. It opens upward and it can open downward. So just you flip it upside down. That one's also pretty simple as well. Let me label that quadratic. And cross that off our list. So technically we have one graph left, that's graph D, but we still have two functions to choose from. And so let's go back over the definition of exponential and cubic and see if we can figure it out. So exponential gets very close to the x-axis but does not cross or touch it. So pretty obvious again, D is exponential. Exponential graphs aren't always going to look like this. They can be going in that direction too, but, and just pretend I'm not touching the x-axis. So keep in mind that you can sort of have different versions of the graph. So your exponential graph is not always going to look like this. Your step is not always going to look like this. Sometimes they can be filled. Sometimes these could be down in the negative part of the graph. Quadratic could be moved over to the left. So you just really need to have an idea of what the shape of the line looks like, and then you should be fine, because then you'll be able to look at all graphs and know which type of graph it is if you know what type of line you have going on. And so I'm going to cross that off our list. And so obviously what's left is cubic, and so I wanted to show you guys an example of cubic, even though in the book it didn't give you that example. I'm going to, because it was an option up here. Cubic, the definition is equations with a degree of 3. The highest exponent is always 3. It looks very curvy. So this one is very curvy. They can have a bunch of different curves, like I said before. And the equation is y equals x to the third, and it's used in physics. So these are our graphs. It's pretty simple, actually. Just make sure you know the shape of the line, and I think you should be good to go.